Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to use logarithms to solve exponential functions and how to use logarithmic properties to simplify logarithmic expressions. How are we learning it? Through the Introduction to Logarithms notes and the Introduction to Logarithms assignment. When can we use this information? To calculate your daily income based on your overall salary. How do we know we learned it? By getting a score of 4 on the Introduction to Logarithms assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Introduction to Logarithms notes, and then I'll give you time to complete the Introduction to Logarithms assignment. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework is to continue working on the Reasoning with Irrational Numbers study guide and any incomplete assignments that you may have. Let's take a look now at the Introduction to Logarithms notes. Our notes begin with the learning goals and success criteria. First, what is a logarithm? A logarithm is a mathematical operation that determines how many times a certain number, called the base, is multiplied by itself to reach another number. So it's just another way of doing an exponential function. So this sounds like the similar definition to an exponent. So how do we rewrite logarithms as powers? So we have log base 3 of 9. That's the way we read this, so log base 3 of 9. So in order to simplify this expression, we must rewrite as a power. So really what this means is we're saying 3 to some power, which we don't know, is equal to 9. So how many times do we multiply 3 by itself to get 9? Well, we know we multiply 3 times 3 to get 9, so that's 3 times itself twice. So x then is equal to 2. Now we have log base 2 of 4. So we need to rewrite that as a power. So really this is saying 2 to some power is equal to 4. So we rewrite that as 2 to the x power is equal to 4. Well, we know that 2 times itself twice equals 4, right? Because 2 times 2 is 4. So x in this case would be 2. All right, so let's actually simplify a few of these. So it says log base 3 of 27. So we're going to rewrite that as 3 to the x power is equal to 27. So we don't know what x is yet. So we're saying that 3 times itself a certain number of times equals 27. Well, in this case, we can see that 3 times 3 times 3 equals 27. So that's 3 to the third power. So in this case, x equals 3. Now, log base 2 of 16. So that's really saying 2 to the x power is equal to 16. So how many times do we need to multiply 2 times itself to get 16? So if we go 2 times 2, that's 4. Times 2 is 8. Times 2 is 16. So that was 4 times we multiplied. So x equals 4. Now what if we're using negative power? So in this case we have log base 4 of 1/4. Well, we can see we went from an integer to a fraction. So anytime we do that, that means we have to have a negative power. So what we're really saying here is 4 to the x equals 1/4. So notice we went from an integer to a fraction, so we need to use a negative power. So what we need to look at here is, as long as this is 1, then we're good. We just need to look at this denominator and see 4 to what power equals 4? Well, 4 to the first power equals 4, so we know it's going to be 1. And because it's in the denominator, we're going to take it and make it a negative power. So this would be 4 to the negative first power equals 1/4. So x equals -1. Now here we have log base 1/2 of 4. So we're saying 1/2 to the x power is equal to 4. Well, we're going from a fraction to an integer. So anytime we do that, that means we had to flip it. So we're going to have a negative power. And then we just need to look. 2 to the what power equals 4? Well, 2 to the second power equals 4. So it would be 2. And then we just need to make it negative so that it flips. So we get x equals -2. Now, what about fractional powers? So in this case, we have log base 9 of 3. So that's really saying 9 to the x power is equal to 3. Well, Notice we start with a bigger number than we end with. So that means that we have to be taking a fractional power of some kind. So 9 to what power equals 3? Well, if we take this is really the square root of 9 is equal to 3. So when we raise it to a power, it's really the 1/2 power. So in this case, x equals 1/2. Now here we have log base 32 of 2. So really that's 32 to the x power is equal to 2. Again, the number we start with is bigger than what we end with. So we know that it's got to be a fractional power of some kind. So 32 to what power equals 2? Well, we can look at it this way. 2 to what power equals 32? So 2 to the second is 4, and then 8, then 16, then 32. So that was 5 times. So we know that 2 to the 5th power is equal to 32. So that means 32 to the 1/5 power equals 2. So x equals 1/5. Now, the logarithmic property of multiplication. So what this says is log base a of b times c. If we can break that up into multiplication, then we can rewrite it in a way that's a little more easy to see. So we have log base a of b times c, and that's equal to log base a of b plus log base a of c. So we can rewrite that as addition. So what does this look like? So let's look at log base 3 of 27. Now we could do this easily and say that 3 to the 3rd power is equal to 27, so it's equal to 3. But let's say we don't know that. Let's say 27 is too big of a number and we need to break it up a little bit. So we can rewrite this as log base 3 of 9 times 3, because 27 is equal to 9 times 3. Then we can rewrite this as log base 3 of 9 plus log base 3 of 3. Now, we can look at this and say 3 to the what power equals 9? Well, we know 3 to the 2nd power equals 9. And 3 to the 1st power equals 3. So that's 2 plus 1, which is 3. Now we can check this by just doing the logarithms. So 3 to the 27th. So that means that 3 to the 3rd power is equal to 27, which is the same as what we ended up with here. Now what if we end up with remainders? So we have log base 3 of 18. Well, when we do this, we recognize that 3 doesn't necessarily go directly into 18, right? We can't multiply because 3 times 3 is 9 times 3 is 27. So we can't actually get all the way to 18, but we can get something out of this. So we're going to rewrite this as log base 3 of 9 times 2. So now we can rewrite this as log base 3 of 9 plus log base 3 of 2. And this part we can simplify. So log base 3 of 9 is the same thing as 3 to the x power is equal to 9. Well, we know that 3 to the 2nd power is equal to 9. So we end up with 2 plus log base 3 of 2. We can't simplify this because we can never go from 3 to 2 by multiplying by powers. So we just leave it just like this. Now here we have log base 4 of 48. So we're going to rewrite this as log base 4 of 16 times 3. And you could do 4 and pull that out, and then you would recognize that there was another 4 that you could pull out as well. So you just keep adding stuff in. But the simplest form from in the beginning is to make this log base 4 of 16 times 3. So we can rewrite this as log base 4 of 16 plus log base 4 of 3. Now 4 to what power equals 16? We should notice that 4 to the 2nd power equals 16. So this is really 2 plus log base 4 of 3. We can't simplify this because 3 is not any kind of a power of 4. So we'll just leave it just like this. So 2 plus log base 4 of 3. Now division property. So we could also write these as division. So we could look at it that way, or this especially works well if our part here is a fraction. So we have log base a of b divided by c, and when we rewrite that, we can say that that's also equal to log base a of b minus log base a of c. So let's take a look at how this works. So we have log base 3 of 1/9. And if we remember back to what we did earlier, we should see that this is -2 should be our answer. So let's see if that's true based on the rule we just learned. So we have log base 3 of 1/9. So this is really log base 3 of 1 divided by 9, because that's what a fraction says. We can break that up then and say log base 3 of 1 and log base 3 of 9, and we're subtracting those. So now 3 to what power equals 1? Well, we know anything to the 0 power is equal to 1. So 3 to the 0 power equals 1, so that's 0. And then 3 to the second power equals 2. So we end up with 0 minus 2, which is -2. Now, if we were to just do it based on this, the way we learned it originally, we said 3 to some power equals 1/9. So this is 3 to the x power is equal to 1/9. We know that it turned into a fraction, so therefore it's going to be negative. So 3 to what power equals 9? Well, 3 to the second power equals 9, and then we make it negative, so it's -2. So we can check our work and see that these two match. Now, how do we do this with remainders? Well, in this case, we have log base 3 of 2/3. So we're going to rewrite this as log base 3 of 2 divided by 3. So just like this. Now we can break this up and say log base 3 of 2 minus log base 3 of 3. We can't multiply 3 by itself any number of times to get 2. But we can do it here. We can multiply 3 by itself one time to get 3. So we end up with log base 3 of 2 minus 1. Now this one, log base 5 of 25 over 3. So we can take this and say log base 5 of 25 divided by 3. And then we can break this up. So this is log base 5 of 25 minus log base 5 of 3. Well, this first part, we can look at 5 to what power equals 25? Well, 5 to the second power equals 25. So this is 2. And we can't multiply 5 times itself any number of times to get 3. So we just leave that part as is. So this becomes 2 minus log base 5 of 3. Now there's a video here that shows you how you can check logarithms using Symbolab. So you can go ahead and watch this video. Let's talk now about how to use the logarithmic equation calculator to check your work when dealing with logarithms. So let's say that we were given log base 2 of 8. So log base 2 of 8, and we needed to solve this. Well, we can go ahead and enter that in and click go, and it tells me exactly what the answer is. It says log base 2 of 8 is 3, and it gives me steps to show me exactly how that works. So that's one way you can check just a simple logarithmic equation. Now let's say there was more to it. So let's say it was log base 2 of 8 plus log base 3 of 9. Well, we can go ahead and click go again. And this time it tells me that the answer is 5 because log base 2 of 8 is 3 and log base 3 of 9 is 2. So therefore the answer is 5. We can also do something like this, log base 2 of 32, and click go. We can also do something like this, log base 2 of 40, and click go. And this time it'll tell us, it gives us a decimal answer, but it also will tell us, using the log rule, that it's 3 plus log base 2 of 5. So we can do it that way as well. And this is how you can check your work using the logarithmic equation calculator on Symboloo.com. Let's take a look now at the Introduction to Logarithms assignment. The assignment begins with our learning goals and success criteria. If we scroll down, we can see the questions. The first one says log base 2 of 8, meaning 2 to what power equals 8? Well, we know that 2 times 2 is 4, times 2 is 8, so that means it's third power, so the answer to this one will be 3. I'll scroll to another one. This one says log base 4 of 2. Well, we know that 2 is smaller than 4, so we know it's going to have to be a fractional power. So we're going to take the square root of 4 is 2. So that's another way of saying square root is 1/2. So it would be the 1/2 power. And we'll continue to answer all of these questions until we get to the end. Then we'll click next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.